I'm Dragan Savic, representing the Water Distribution Systems Analysis History Project. The purpose of this project is to document the history of water distribution systems analysis, and as part of it, a series of interviews with engineers, modelers, researchers and practitioners will be conducted or are being conducted, and with those people who made significant contribution to the field of water distribution system analysis. Our interview today is with Professor Juan Saldarriaga. Juan is a professor of hydraulic engineering in the Civil and Environmental Engineering Department at Universidad de los Andes. He's also holder of PAFCO chair, an industrial chair, and he's conducting research in pipeline hydraulics, water supply systems and urban drainage systems. He's also the director of the Water Distribution and Sewerage System Research Center at the university. Among many other administrative and high administrative roles, he held the Vice Dean office in the engineering school at Universidad de los Andes, and also he was a visiting professor at the University of Newcastle upon Tyne in the UK. He has over 30 years of research experience in hydraulic engineering with application to design and management of water systems and urban water systems in particular. This interview is being conducted on the 2nd of September 2015 in Leicester, UK, during the 13th Computing and Control for the Water Industry Conference. One, you're very active in water distribution systems analysis and CCWI conference series. You're actually organizing the next Water Distribution Systems Analysis Symposium in Cartagena, Colombia in 2016. Can you tell us how you came to be involved in water resources systems analysis, and at what stage in your career you decide this was the direction you wanted to pursue professionally?
Okay, thank you very much, Dragan, for that introduction. Regarding my involvement, my history involvement with these urban hydraulic systems, it go back quite a lot. It begins in 1981 when I was a postgraduate student at Newcastle University here in the UK. Newcastle upon Tyne University in the UK. I was a student there, and I chose one topic of research that was pipeline hydraulics under the advisory of Professor Ronald Featherstone. At that time, also Professor Ezio Todini was working with Enda O'Connell in developing, which became later on the gradient method for the calculation of water distribution systems analysis. I was at the university at the same time, and I was taught about this new method by Professor Featherstone, and that's why I became involved in this topic. When I went back to Bogota, where after the postgraduate studies, I started to work in the university. At the beginning, I was working with several hydraulic systems, especially with hydraulic structures related with large hydroelectric projects. The reason, hydroelectricity is very important in Colombia and as well in South America. After that, maybe the year was 1994, I became related with this PAFCO manufacturer, which is the largest manufacturer of pipelines in Latin America, and I got what it is called the PAFCO chair since that year. So it's over 20 years of continuous working with in research of pipeline system, both for water distribution systems and sewer systems. And after that, in year 1996, we got a research allowance from the Colombian government to produce what is known nowadays as the Colombian regulation for the design and construction and operation of water distribution systems and urban drainage systems in Colombia. Since that year, we created the research center in Water Supply and Sewage System Research Center, which has now close to 20 years of continuing working in the topic.
Being based in South America, can you tell us a bit more about the specific issues in water distribution systems that are particularly important for that part of the world, and how these issues influence your research at Universidad de los Andes?
That is a very important question, because what you find in Latin America, not only in South America, but also in Mexico, the Caribbean, Central America, is that we are having quite a lot of problems related with water supply and sewage systems, and this is very common in all Latin America. For example, coverage. If we think about the percentage of people receiving potable water 24 hours a day, 7 days a week, maybe it's only 70-75% of Latin American population. And that figure is a little bit lower if you think on the terms of urban drainage sanitary systems. So that's one of the main problems. We should work quite a lot on improving those numbers. Second, which is more important, is the lack of scientific support for the operation, construction, and maintenance of those systems. In the past, they were constructed using probably international help, but not nowadays, especially in small towns in Latin America. So there is an immense gap between what is happening in design, construction, maintenance, and operation of these systems in the United States or in Europe that in Latin America. So we have to struggle with that through education and through research. And also we are having some real hard water quality problems in water distribution systems. So this is a new problem, and we are not used to deal with, because it's a problem that is appearing in the last maybe decade only.
Okay. You have been very active in the development and application of systems analysis related to the design and management of water distribution systems. Can you describe and summarize the major research questions you addressed, and what is the current state of research, and where your research in that area will focus in the future?
Yeah. The answer to this question is related to the previous question. One of the problems, it's not the only one, but it's one of the main problems that we have in South America and in Latin America, is the cost of the system, the construction cost of the systems. For some of these small towns or even middle-sized towns, sometimes the construction cost is very high, so the municipality they simply don't have enough money to construct the system. This is especially true for the rainwater drainage system, and in some cases the sewage drainage system, but as well in some cases the water supply system. So our main research was focused for the past maybe 15 years in reducing those construction costs through the optimization of the design of systems, water supply systems, sewage system, in order to bring those costs down. At the beginning, when we started to see those costs, then we discovered that the quality of the engineering design for those systems in Latin America was really low, producing very expensive systems, difficult to operate, and in sometimes even they didn't complain with all the hydraulic restrictions given by the local law in some cases. So that was the main topic. Nowadays, it's becoming a little bit more related with water quality, again in water distribution systems.
Could you tell us a little bit more of your research in that optimal design of water distribution systems and the particular methodologies that you've developed?
Yes. Our approach was a little bit different because, again, we wanted to find a method that was easier to understand for practitioners, practical engineers, people working in the water industry. Because what we found in literature was very good methods, but always based on high mathematics. That in some cases is very difficult to understand to the typical Latin American engineer involved with those systems working with public utilities. So our main focus was to understand an energy-based method which was easier to grasp by a practitioner, and with that we got very good results compared with what you find in literature. At the beginning that was only in water supply systems, but we are now applying the same sort of ideas to sewer systems with the same sort of success.
You seem to have a very close relationship with the industry in Colombia. Can you tell us more about your involvement with them? For example, your PAFCO chair for over 20 years now being in place. And how do they influence the research that you do, and how that influence your future plans?
Yes, I can tell you about the two different cases. One is this involvement with PAFCO. PAFCO is the largest plastic pipeline manufacturer in Colombia, but it is part of a very large Latin American manufacturer, which is called Mexican. It's by far the largest pipeline manufacturer in Latin America, and I think is one of the largest in the world. 20 years ago, they started to introduce plastic pipelines, mainly PVC pipelines, to sewer system. That was a new material for those systems in Latin America. And the reaction of the water utilities and the reaction of the practitioners, the practical engineers doing the design, was not very good towards those new pipelines. They do prefer the oldest material, the traditional material, that in the case of sewer system was mainly concrete and in some cases vitrified clay. So PAFCO asked us to support them in introducing that new technology in Latin America. So we created what it is called the PAFCO chair to develop research on pipeline systems. And it has been over 20 years of marriage between the university and this industry with quite a lot of success. Nowadays, plastic pipelines are the most common material, both for water supply system and sewer system in most of Latin America. Mainly PVC, polyethylene, and nowadays for a small water supply system, also polypropylene, which is the newest material. That's one case. The second one, and of course having that chair implies that I have to make research, have students to make undergraduate projects, MSc thesis, PhD thesis on topics related with water pipeline systems. On the second hand, we have the involvement with the Colombian government as well with some other governments in Latin America. One example is Ecuador, another example is Peru, related with developing legislations, standards for the design, operation, maintenance, construction of urban water systems. So at the beginning, we had to study quite a lot of the different legislation, the different standards, the different manuals from North America, Europe, Australia, the developed world, just to see how to have new standards for Colombia and then for Latin America. It was a surprise that when we started to see that the legislation in Latin America was very old, was poor compared to the developed world legislation. But also it was a surprise how easily was accepted by the engineers once that legislation is written. So nowadays we keep doing some research on the impact of that new legislation on especially the operation of the systems.
Juan, you have mentored numerous postgraduate students, and when I visited you in your center, you have a large group of young and enthusiastic people working in this area. Can you tell us a little bit more about your work that you do with postgraduate students? How do you get them interested, because most of them used to be your undergraduate students?
Yeah, and that's right. What I try to do is to identify, to choose those students in the first undergraduate course that I teach to them, which is fluid mechanics. Fluid mechanics is taught, I think, in the 4th or 5th semester of their career, so they are quite young. So I talk to them about the research center, about the research topics, and some of them become interested, and they are eager to work in the research group. So they can, typically a student can work 2 years as an undergraduate, and by the end of these 2 years, he or she makes the undergraduate project, and then they continue with the support of one of the research projects as an graduate assistant, which means he or she is a MSc student paid by the university, working in one of the projects, and at the same time choosing her research topic for the MSc thesis, very related with what they are doing in the paid research they are involved with. So that's more or less how it works. The research center more or less has typically 15 graduate students, MSc students, maybe 20 undergraduates, and 1 or 2 PhD students, all supported by their research projects.
Finally, I would like to ask you a general question about future direction of your research, and what areas should the profession, or what areas of research should the profession undertake in the next 20, 30 years ahead? Okay.
Again, still there is the problem of the lack of 100% access to water distribution, to potable water for the Latin American population. We should keep working on that, but there is a special topic that is going to affect us quite hard, and that it is climate change. For Latin America, it means climate change means less rain, so that means less water in some parts of Latin America. So in those parts you are going to have quite a lot of problems related with the water supply systems. Lack of water, access to water, that's going to be a hard problem. So that means that, for example, leakage should be very low. And nowadays leakage is a high problem in many places in Latin America. That's related with water supply systems. On the other hand, in some other places in Latin America, that's the case of the tropical cities on the Andes. That means cities in Venezuela, Colombia, Ecuador, and the northern part of Peru. For those cities, climate change will mean higher intensity rain events and also more frequent rain events. So that means that the current drainage systems, they don't have the capacity to move all the water that is going to rain in the next years. So that means that the research should be done on how to make this already constructed system to operate under a different hydrologic aspects of these rain intensities. It's not possible to replace all the system, it's too expensive. So the research should be on what sort of measures you can do to, with the same infrastructure, handle heavier rains. Those are two hot topics for Latin America.
Thank you very much, Juan.
Okay, thank you very much.